In this video, we are going to learn about Newton's laws of motion. Newton gave 3 laws governing the motion of the bodies. So Newton's first law. According to this law, a body continues to be in its state of rest or of uniform motion along a straight line unless it is acted upon by some unbalanced external force to change the state. Unbalanced external force to change the state. So according to this law, a body at rest would remain at rest and a body in uniform motion would continue to do uniform motion unless and until the body is compelled by some external force to change its state of rest or of uniform motion. Okay, so if a body is at rest and this body is in uniform motion, and if there is no external force, then this body would continue to be at rest and this body will continue to be in uniform motion, and this is Newton's first law of motion. So let's understand this law. So force is mass into acceleration. Force is 0 implies that acceleration is 0, assuming mass is not 0 of the body. Then if acceleration is 0, then no change in velocity, or change in velocity is 0. Change in velocity is 0, or velocity is equal to constant. What this means? This means if external force is 0 on the body, then velocity of the body will be constant. So for a body at rest, velocity is 0, and if no external force acting, that is F is equal to 0 on this body, then this velocity will be constant, which means this velocity will continue to be 0. If velocity of body is some constant a, then it will continue to be a. That is, if external force on the body is 0, then body will continue to move with velocity a. That's why if no external force acting on the body, then a body at rest, then a body at rest will continue to be at rest, and a body in uniform motion will continue to be in uniform motion. Newton's second law of motion. This is a very important law. From this law only we obtained this relation which I was using earlier to explain Newton's first law of motion. So using Newton's second law of motion, we can explain Newton's first law of motion, and we can also explain Newton's third law of motion. So what is Newton's second law of motion? According to this law, the rate of change of linear momentum, the rate of change of linear momentum of a body is directly proportional to the external force applied on the body. And this change takes place always in the direction of the force applied, and this change takes place always in the direction of force applied. So according to Newton's second equation of motion, the rate of change of linear momentum is directly proportional to the force. So we can write as F proportional to the rate of change of linear momentum. Here d by dt is first derivative of linear momentum with time. dmb is change in linear momentum in time dt, and dt is taken to be very small. So this is very small change in linear momentum in very small time. So this is equal to the rate of change of linear momentum. So rate of change of linear momentum is directly proportional to the force according to this law, according to the second law. So we can write this as F is directly proportional to d by dt of mb. If you have studied the laws of derivative, then m is constant and we can take it out. So this becomes m d by dt of velocity, and this is nothing but acceleration, as rate of change of velocity is acceleration. So this becomes f directly proportional to m into a. And when we measure force in Newton, mass in kg, and acceleration in meter per second square, that is when we measure this quantities in SI unit, the proportionality constant comes out to be 1. So here 1 is proportionality constant is 1. When these quantities are measured in SI unit. So from Newton's second law of motion, we have force is equal to mass into acceleration. So force is equal to rate of change of linear momentum, as proportionality constant is 1. So if force is 0, this means that rate of change of linear momentum is 0. This is nothing but linear momentum. So we can write it as d by dt, and p is linear momentum 0, which means that linear momentum is constant. So when external force is 0, the linear momentum is constant, and this is obtained from Newton's second law of motion, and this is very important result. So we just obtained that when external force is 0, the linear momentum of the system is constant. From this we obtain the law of conservation of linear momentum. According to this law, in an isolated system, isolated system is a system on which net external force is 0 or no external force is being applied. So F is 0 here. So in an isolated system, the linear momentum of the system is conserved. The linear momentum is conserved. So this is nothing but this result, that in an isolated system, that is when external force is zero, the linear momentum is conserved, that is linear momentum is constant. So this is nothing but this result which is obtained from Newton's second law of motion. We can use this to find the recoil velocity of gun. Consider a system of gun and bullet. Gun and bullet are at rest initially. So before firing the bullet, the velocity of gun is 0 and velocity of bullet is also 0. No? So let's say u1 is velocity of gun and u2 is velocity of bullet. So both are at rest, so both are 0. So linear momentum before firing the bullet, that is m1 u1. So considering m1 to be the mass of gun and m2 to be the mass of bullet, to m2 u2. So this is initial momentum, that is momentum before firing the bullet, and it would be 0 since u1 and u2 both are 0. So this will become 0 and this will also become 0. So linear momentum, total linear momentum of this system of gun and bullet before firing the bullet, which initial linear momentum is 0, and since no external force is acting, then final linear momentum, that is linear momentum after firing the bullet, will also be 0, since linear momentum is conserved when no external force is acting on the gun. So final linear momentum, Lm is linear momentum, is 0. So after firing the gun, bullet moves with velocity v2 and recoil velocity of gun is v1. Then m1 is mass of gun into v1 is velocity of gun plus m2 is mass of bullet into velocity of bullet. This is final linear momentum, or linear momentum after firing the gun. So it will be 0 since linear momentum before firing the gun was 0, and from this we can obtain the recoil velocity of gun. It will be m1 v1 is equal to minus m2 v2 when we move this m2 v2 to right hand side, and from this we can obtain v1 to be minus m2 v2 on m1. Minus is because the direction of v1 is opposite to the direction of v2, so we will use vector sign as from velocity, as velocity is vector. So recoil velocity of gun v1 is equal to minus m2 v2 upon m1, where v1 is recoil velocity of gun, m2 is mass of bullet, v2 is velocity of bullet, and m1 is mass of gun. Now Newton's third law of motion. According to this law, to every action there is always equal and opposite reaction. To every action there is always an equal and opposite reaction. That is, if body A, this is body A and this is body B, if body A exerts a force F1 on body B, then body B will exert a force of F1 on body A. Also notice that action force is being applied on body B by body A. Action force on body B and reaction force is acting on body A. So since action and reaction force are acting on different body, so that's why they do not get cancelled. Now let's study about impulse of a force. It's a measure of total effect of the force. Impulse is equal to average force into time. So impulse is given by the product of average force and time for which force acts on the body. So if force, so by Newton's second law of motion we know that force is equal to rate of change of linear momentum, and we can write this as force into dt is equal to dp, integrating both sides from time 0 to t, and from momentum, that is initial momentum, to final momentum during time 0 to t. So we have force to dt is equal to dp, and this is from p1 to p2, and this is from 0 to t. And if force is not constant throughout, then we can take force to be average force. Then we will have a force average to dt is equal to integration from p1 to p2 dp. Integrating both sides, force average is constant, so we can take it out common. The average force is constant, then this will become 0 to t dt, and which is equal to p1 to p2 dp. This will be force into time 0 to t is equal to momentum p1 to p2. Like that, force, average force into time into 0 is equal to p2 minus p1. Or average force into time is equal to p2 minus p1. So change in linear momentum is equal to p2 minus p1 is equal to average force into time is equal to impulse. Force versus time, then this area is given by integration t1 to t2 f dt, and this is equal to impulse. So impulse is given by the area under force versus time graph. Using second law of motion we can obtain Newton's first law of motion and Newton's third law of motion. So let's see how. Newton's second law of motion says that force is equal to mass into acceleration, and if force is equal to 0, acceleration will be 0, and which means the velocity will be constant. So a body at rest will be at rest, and a body in uniform motion will be in uniform motion if no external force is applied. And this is Newton's first law of motion. So using Newton's second law of motion, we can obtain Newton's first law of motion. Now let's see how we can obtain Newton's third law of motion from second law of motion. So as we know that from impulse, force is equal to rate of change of linear momentum, that is d by dt p, and from this we just obtained in impulse section that this is equal to f dt and dp. So this is equal to change in linear momentum is equal to average force into time. So consider a collision between body A and B, and during collision body A exert a force F1 on body B. This is action force, and body B exert a force F2 on body A. So consider collision between two bodies A and B, and during the collision body A exert a force F1 on body B. We can consider this as action force, and body B, during the collision body B exert a force F2 on body A. So change in linear momentum is equal to force into time. So change in linear momentum of B. So change in linear momentum of body B. So force on body B is F1, and let's take a small time delta t for which collision occurs. And change in linear momentum of body A will be change in of body A, and change in linear momentum of body A will be force on body A, that is F2, and for time for which collision occurs. So total change of linear momentum during collision is F1 delta t plus F2 delta t. Since the system of body A and B was isolated, that is no external force was acting, so linear momentum will be conserved. So linear momentum of system A and B will be conserved or constant. So change in linear momentum will be 0. So change in linear momentum of body B plus change in linear momentum of body A, that is total change in linear momentum of system A and B, will be 0, since no external force is acting on body A and B. That is system of body A and B is isolated. From this, if we cancel out delta t, we can obtain F1 is equal to minus F2. action force is equal to minus reaction force. So this is Newton's third law of motion. So from Newton's second law of motion we have also obtained Newton's third law of motion.